My name is Jim Miller. I'm here to spend a few minutes with you reviewing some of the properties of the noise survey instruments, in particular the sound level meters and the octiband analyzers. We're going to look at the cell instruments, and in doing so, these are representative of what OSHA has in the field and are not meant to be in any way an endorsement of these instruments as having some unique or superior property over other products, merely what OSHA has available. We have three objectives in this session that we'd like to cover. The first objective that we have is to look at the properties and functions of the instruments. The second is probably one of the more important of this set of objectives, and that is the calibration of these instruments. And the third is a few reminders on the use of the instrument when they're actually being used in the field. As a reminder, in this session we will not be covering the dosimeter. The dosimeter is our primary compliance instrument. So don't forget about the field operation manual guidance for policy and your OSHA technical manual chapter 4 noise measurements when it comes to the dosimetry aspects. What we're covering here are the type 2 cell sound level meter, which would be used for screening survey purposes, referral purposes, and perhaps on occasion backup readings. The other instrument that we're covering is the cell sound level meter that's used for octiband analysis as well, and perhaps impact noise. With those two instruments, you may be using the OSHA 92 form, particularly with the type 1 precision instrument. Please, before and after you use the instrument, document your calibration findings on the back of the form. Also, be sure to include the A and C reading, wherever that is feasible to do so, on the front of the OSHA 92 form. The OSHA 99 form is used for your octiband analysis, such as for an audiometric test room, or if you're doing evaluation for engineering controls, hearing protectors, or whatever reason is deemed appropriate at the time. That information goes on the OSHA 99 form. The other information that can go on the OSHA 99 form is the peak noise, impact, impulse noise. Again, another reminder, the federal standard is a should statement. All noise forms are included in the dosimetry and the total noise analysis, but it's a should statement for the 140 decibels for impact, impulse noise in the federal standard. Some state standards have made that a shall statement. With that then, let's look at a few of the features of the instruments. The instrument that I have here is the basic standard sound level meter. It's a type 2. Type 2 means plus or minus 2 dB error according to the ANSI, American National Standards Institute guidance for these instruments. So we could be off by plus or minus 2 decibels from the real value. The microphone here is protected by a plastic cover, which I'm now going to remove. And that cover is very helpful in preventing the microphone from being bumped or damaged, and it's very sensitive to that type of trauma. We have a response switch. Simply flick it down to put it in the fast position or the slow position. And we have a range switch, high and low. Low starts at approximately 30 dB and goes up. High starts at 65 and goes up. As far as powering this unit, it's powered by 4 AAA batteries, which can be observed by pressing on the center plate. And you'll have 2 in the front and 2 visible from the rear. It's extremely important that we use fresh batteries, and if we anticipate storing this for a prolonged period of time, that we remove the batteries to prevent damage that might occur because of leakage or prolonged storage effects. The other instrument that we have is a precision instrument. This particular instrument can be used for octiband analysis, peak noise analysis, A and C weightings in support of noise dosimetry. It has a variety of features which go beyond the ones that we're going to take a look at. But this instrument, as with the other ones, some properties that are important. Microphone is sensitive to bumping type of damage. The microphone is sensitive to wind error. The microphone can be damped by moisture condensation, so accumulation of moisture would be unacceptable. The microphone can be interfered with by dust. The microphone can be interfered with by electromagnetic fields. So anytime you think you have one of these problems, if you're uncertain as to what's best to deal with them, please contact your supervisor. One way of dealing with the wind effects is to use a wind screen. Okay. The calibrator that we're going to use is a cell calibrator. It operates simply with an on-off switch. When it's first turned on, a light comes on momentarily, then goes out as it presents a tone of 1,000 hertz with an intensity of 114 decibels. It's powered by a 9-volt battery, which can be found by removing the back cover of the unit. In summary, for the function and properties, we've got a type 1 instrument, a type 2 instrument. It's very important that we use fresh batteries, alkaline batteries, 9-volt for the calibrator, AA, 4 of these for the precision type 1 instrument, the octave band analyzer, and AAA alkaline batteries for the standard sound level meter, the type 2. Now we'll turn our attention to calibration. First we'll calibrate the type 2 sound level meter, and then we'll calibrate the type 1. In calibrating this instrument, we have 2 different sizes of microphones. In order to ensure a snug fit between the microphone and the calibrator opening, we need to place an adapter in the calibrator opening, which I will now do. For calibration, we want the response switch in the fast position, the F position. We want the range in the high position. We'll turn on the calibrator. Calibrator is putting out 114. So when we combine these two, and we do this gently so we don't damage the microphone, we should get 114.0, which is what we're getting here. If we were not getting 114.0, we would take a screwdriver, insert it in the CAL position here, and gently turn with the screwdriver until it did read 114. In this manner. Okay, we want to do this before we do a screening, or before we do measurements for possible referral, and after we've completed the workup that we're going to do. After we've completed the calibration, a critical element here is the documentation. Can't emphasize that aspect enough. So we record the manufacturer, recommend you record the model number, and also it's essential that you put down the serial number of the instrument that you are planning to use or will be using. In addition, identify the calibrator that you're using and document its serial number as well on the appropriate form for the type of survey that you're doing. Keeping in mind that whether it's this instrument or others, always refer to the manufacturer's literature for the particular instrument in question. Okay, A-fast for the type 2 instrument. For the type 1 instrument, to set this up, we'll put the range switch on 80. We'll go to the A setting. We'll go to the fast setting, which is F. We'll turn it on, allow it to go through its internal check. It's checking now the internal circuitry. It says cell 266, voltage 5.15. If I was going to be using this for any period of time, I'd probably start thinking about fresh batteries and try and have a range of 5.8 to 6.2 for this evaluation. To calibrate this, it's a single point calibration. I turn on the calibrator. I gently place the calibrator on the microphone. So I'm going to have the range switch 80, A fast on, and I should get a reading of 114.0. If I did not get a reading of 114.0, I would take a screwdriver and carefully insert it where it says CAL in the middle of the face and turn the screw in there until I got as close to 114.0 as I could possibly get, and that would constitute the calibration of this instrument. Once I've calibrated this instrument, I again carefully separate the two units, turn off the calibrator, turn off the instrument if I'm not going to use it in the near future, and I go into the second part of this, again, which is very critical. I would document that this is a cell instrument. I would document the model. I would document its serial number. Serial number I could find in the back. I'd also need to identify the calibrator that I've used. In this case, it's a cell calibrator, and its serial number. Periodically, typically once approximately a year, this calibrator needs to have an acoustical check to ensure that it's actually putting out 114 and that it's complying with the specification. So check with the literature on that. Single point calibration for both. Once we've done that, we have finished the process of calibration and documentation. We'll now turn our attention briefly to the use of these two instruments. Again, I'll start with the Type 2 instrument and then go to the Type 1 instrument. With the Type 2 instrument, we're primarily going to be using this as a screening device or as a referral device. We're going to get sound level measurements. We're interested in A slow. So we're going to have the A in the appropriate range and slow. The microphone is sensitive to the various types of interferences that we've talked about, and our concern in this measurement is employees. So we need to have employees present. They need to be exposed to what we're dealing with. So typically we're talking about employee exposure here, and we're talking about the hearing zone of an employee, and that hearing zone is a 2-foot sphere around the head of an individual. The Type 1 instrument gives us a little more flexibility than the screening instrument, in that the Type 1 instrument can be used to help fill out the OSHA 92 form, where we get A slow as required by the standard, and also C slow, Charlie slow, as supporting backup readings, which help us do frequency analysis or give us some idea of the type of noise pattern that we have. In addition to helping us with the OSHA 92 form, this can be used to do octave band analysis and peak analysis. We'll take a moment to look at both of these. To do octave band analysis, we simply move the weighting switch to FL, leave the time response switch in slow, and then adjust the range switch as appropriate to get a reading. It is now, according to the pointer, triangular pointer, in the octave band for 31.5. The function buttons allow us to move the pointer to the various octave bands. So by pressing this once, I'm now up to 63, that particular octave band center. I get my readings and move on through the octave bands using the function buttons. When we're doing octave band analysis, typically the digital readout here is an LEQ, so it's a form of moving average. The lower hatched line, dashes, is the instantaneous readout. For the most part, you'll probably want to go with the instantaneous readout, and that is a more realistic measure and it will not have some of the problems that you have with trying to read the LEQ. In addition to doing octiband analysis, which we might do for engineering controls, we might do for hearing protectors, we might do for audiometric test booth or test rooms. In addition to that, we may wish to look at peak noise because of its presence or because of potential overexposure. To do peak noise, we can bring the range back up to 80, we can go to C, we can go to P, and now we will get a readout of the peak noise. We can reset our instrument by using the red reset button. So we have options then. We can use this to complete the OSHA 92 form. We can use this to complete the OSHA 99 form. And in summary, keeping in mind a couple of things. One, when we're taking these measurements, we need the hearing zone of an employee. Two, noise behaves like light. Okay, so the second one is noise behaves like light. If you can interfere with light, you can interfere with noise. If we hold it too close, we can get interferences related to the body. So at a comfortable distance. If there's wind, it can give you erroneous readings. If there's dust, it can damp out the instrument. If there's moisture, it can damp out the instrument. If there's electromagnetic radiation, it can interfere with the reading. If you have questions about these in a situation you're looking at, please contact your supervisor for further input. Thank you.